I am FARRAH HIERRAS.
Hi, I'm Marcon de Castro.
And I am Joizel Cuaresma.
You are watching Husay Tama Raw.
Episode 7 entitled Experiment 5, Finding Mr. Acid and Mrs. Base.
For today's episode, I would like you to ask if you know what vinegar and baking soda is. Do you know that vinegar is a type of an acid with a chemical name acetic acid? And baking soda is a type of base with a chemical name of sodium bicarbonate? These two things are commonly found in homes and are common materials for a simple chemical reaction.
So how do you really define an acid and a base?
That's a good question, Farah. There are a lot of theories that define and differentiates the acid and the base. But for a simpler definition, an acid is the one that donates hydrogen ions and accepts electrons in a chemical reaction. When there is a higher concentration of hydrogen ions, a solution gets more acidic or it has a lower pH level. On the other hand, bases are proton acceptors and electrons donor, opposite to acids. The more concentrated the base's hydroxide ions, the more base or higher pH level it has.
In regards to this, our experiment for today will focus on determining the pH level of different solutions. To start off, let us first prepare our materials. For our samples, we will need 1 teaspoon of water, 5 drops of calamansi or lemon juice, 10 drops of freshly squeezed tomato juice, 2 tablespoons of vinegar, 2 drops of colorless or white shampoo, 1½ teaspoon of baking powder or baking soda, 1/8 teaspoon of laundry soap, 5 drops of liquid bleach, 3 drops of muriatic acid, 2 eggplants for our pH indicator, clear plastic cups, heat-resistant container, dropper, 10 ml syringe, and white paper.
But before we begin the actual experiment, make sure that you are also wearing protective equipment as some of our materials are harmful. Be extra careful when working with muriatic acid as it can burn the skin upon directly intact. We don't want to burn ourselves, right?
On the other hand, we cannot perform our experiment if we do not have a pH indicator. Do you know that we can make one from a vegetable inside our home? Yes, you heard it right. Grab your eggplants and let's do it.
First, we need to peel 2 eggplants. Then, get its skin. Let it air dry for 1 to 2 days without direct sunlight. In this case, you really need to prepare ahead of time to achieve this material.
Next, boil 250 ml of water, then remove it from the heat. Let the eggplant skin soak in the hot water by putting it in a heat-resistant container.
Now, we will prepare our samples. Grab your plastic cups and label them of your chosen samples we will be using today. Make sure that each cup will only get 1 sample. You should only have 5 cups of your chosen samples. 1 of these cups should only have water. For ours, we will use a vinegar, baking soda, calamansi juice, and bleach for the samples.
For the other cups, add another 5 ml water and mix it well. Once you have prepared it, grab your eggplant peel's pH indicator and add 10 ml of it in each cup. See? The color of the solution is changing. Make sure to record this beautiful event.
You can also add more if you want it to be more vivid in terms of colors.
Wow, that's amazing!
Indeed! Now, we will search the pH value of the samples. Based on our experiment, refer to the color change happening in the solution and determine whether the solution is acidic, neutral, or basic.
That is so easy, what a way to determine the pH level. But let me explain to you about the results. When we add the water to each sample, the water mixes with them. This helps to easily mix our pH indicator with samples. And upon adding the eggplant peel pH indicator in the vinegar, its color turned almost purple. If we look at the pH level chart, it indicates an acid since it is below 7, specifically the value of 5 to 6. For calamansi, it is somehow reddish to orange-ish color with a pH level of 2.4.
But when we added the pH indicator to the baking soda, it had turned bluish to greenish with a pH level of approximately 9 indicating a base sample. Yellowish color is achieved upon mixing the bleach and the pH indicator. This color indicates a pH level of a base around 11 to 13.
However, if you will look at water, there seems to be no changes at all, since water is considered to be neutral, having a pH level of 7.
You may ask how we determine the pH level of the samples here in our experiment. Well, this happened because of our pH indicator. Included in this indicator is the anthocyanins. It is a kind of flavonoid with antioxidant effect and can be found often in various foods including eggplant. This is the compound responsible for the rich color of red, blue, and purple.
So when this anthocyanin reacts with samples at various pH levels, the molecular structure of the anthocyanin is changed. It is much more stable at low pH samples, resulting in a red color. But when it is mixed with a higher pH level, it creates a color of bluish to purple.
Although in this kind of experiment, red cabbage is often used, the eggplant still works as a pH indicator since it still contains an anthocyanin, the main thing responsible for the color change that would indicate the pH level of a sample.
Therefore, we can conclude from this experiment that a sample that is acidic will appear reddish, orange-ish, or yellowish upon mixing with a pH indicator. The value of pH upon these acid samples is said to be lower than 7. On the other hand, bases will appear bluish to purplish upon mixing with a pH indicator. This has a pH value greater than 7. And water will always be considered neutral, having a pH level of 7. This means that water can be an acid or a base.
What a fun experiment, isn't it?
Yes, I did enjoy it. Plus, I even got a chance to explore more about acid, base, and pH level. I hope you too are able to learn with us.
We are looking forward to some more fun Husay experiments with you, Tamaraos.
Thank you for staying with us until the end. See you next time!
This is Husay Tamarao, signing off! Bye!